Hello everyone, welcome to my channel Chemistry is Fun. Today we will deal with the topic solutions. It is meant for class 12 and this is part 4 of the topic. We will deal with vapor pressure of liquid solutions. Now liquid solutions are formed when the solvent is a liquid. The solute can be a gas, liquid or solid. We will see vapor pressure of liquid solutions. Today we will see vapor pressure of liquid solutions. Now see, first of all, in a binary solution of two volatile liquids, the two components are denoted as 1 and 2. When they are taken in a closed vessel, both the components would evaporate and eventually one equilibrium will be established between the vapor phase and the liquid phase. Now if the total vapor pressure at this stage is P total, P1 and P2 are the partial vapor pressures of the two components 1 and 2 respectively, and we have to see the mole fractions. The mole fractions are x1 and x2 of the two components 1 and 2 respectively. In this situation, if we see Raoult's law, now for a solution of volatile liquids, the partial vapor pressure of each component of the solution is directly proportional to its mole fraction present in the solution. So for component 1, P1 is directly proportional to x1 and P1 equal to P1 naught into x1, where P1 naught is the vapor pressure of pure component 1 at the same temperature. For component 2, P2 is equal to P2 naught into x2. Here P2 naught represents the vapor pressure of pure component 2. Now as per Dalton's law of partial pressures, the total pressure over the solution phase in the container will be sum of the partial pressures of the components of the solution. So P total will be equal to P1 plus P2. Now if you substitute the values P1 and P2, we get P total equal to x1 P1 naught plus x2 into P2 naught. But x1 is equal to 1 minus x2. By substituting this, we get 1 minus x2 into P1 naught plus x2 into P2 naught. On opening this bracket, P1 naught minus P1 naught x2 plus x2 P2 naught. So here it will become next step P1 naught here same plus x2 we can take common, so we get x2 into P2 naught minus P1 naught. Now if we see this graph, this is between the vapor pressure and the mole fraction. Here we see x2 equal to 0, x2 equal to 1, 0 to 1, whereas x1 is equal from 1 to 0. And you see P1 naught, this is P1 naught, this is P2 naught. So based on this, we can conclude that the total vapor pressure over the solution can be related to the mole fraction of any one component, and total vapor pressure over the solution varies linearly with the mole fraction of component 2, as we have seen with this one, x2 equal to 0 up to x2 equal to 1. And depending on vapor pressure of pure components 1 and 2, the total vapor pressure over the solution will either decrease or increase with the increase of mole fraction of the component, here component 1. Now if we see the plot of P1 and P2 versus mole fraction x1 and x2 for a solution, we get a linear plot. The minimum value of P total is P1 naught and maximum value is P2 naught. Here we assume that component 1 is less volatile than component 2, so P1 naught is less than P2 naught. Now if y1 and y2 are the mole fractions of components 1 and 2 respectively in the vapor phase, then Using Dalton's law of partial pressure, we get P1 is equal to Y1 into P total, P2 is equal to Y2 into P total. In general, we can write Pi is equal to Yi into P total. Let us see one numerical. The question goes like this. Vapor pressure of chloroform and dichloromethane at 298 K are 200 mm mercury and 415 mm mercury respectively. Calculate vapor pressure of solution prepared by mixing 25.5 gram of CHCl3 and 40 gram of CH2Cl2 at 298 K. Now see, we will solve like this. First we find out the molar mass. Molar mass of CH2Cl2 is 85 gram per mole. Molar mass of CHCl3 is 119.5 gram per mole. We find moles. Moles of CHCl3 will be 25.5 gram, which is given here, divided by 119.5 gram per mole, so it is 0.213 mole. For moles of CH2Cl2, we divide 40 gram, which is given, by 85 gram per mole, we get 0.47 mole. Total number of moles equal to 0.47 plus 0.213, that is equal to 0.683 moles. So we find X for CHCl2, so this 0.47 we observed here, divided by 0.683 mole, which is the total number of moles, we get 0.688. So for XCHCl3 will be 1 minus 0.688, that is 0.312. Now using the formula P total is equal to P1 naught plus P2 naught minus P1 naught into X2. Put the values. P1 naught 200, P2 naught 415 minus P1 naught, which is 200, into 0.688. We get 200 will come here, and 147.9. So finally we get it as 347.9 millimeter mercury. I hope students you all could understand the topic which I discussed today. Thanks for watching my video. Please share the video and subscribe to my channel. Thank you all.